the ENGOF by presenting you with a test item. Here's a case, a patient vignette, and a multiple choice question. Suppose you are a judge in a panel, let's say, of 8, 9, or 10 different people. And I would like you to read this case, this multiple choice item, and I'm going to ask you a very, very difficult question. But first I would like you to think of the borderline candidate. Let's say this test question is administered in a final examination of the undergraduate medical curriculum. Could you imagine a borderline student? Someone who could just fail or pass, not the strongest candidate. The difficult question which I'm going to ask you is to give an estimate in a percentage. What the percentage you think would be that this particular borderline candidate would pass this test question. Let me repeat it once more. It's not an easy question, but I would like you to give an estimate on a scale from 0 to 100%, the chance with which the borderline candidate would pass this particular question. And I know it's a very difficult question. Normally, we can discuss the borderline candidate within the panel of judges, but I want you to make an estimate at gunpoint, and you have to do it. Then there are various procedures and variations in the ENGOF procedure. For example, once you've given your estimates, we could discuss the estimates among our panel. And as a result of this discussion, for example, you might motivate why you gave a particular higher estimate and someone else gave a particular lower estimate. And as a result of this discussion, we could then revise our judgment. When we're done, the second alternative would be if we would provide performance data, like the average score of the group of students who have taken this test. Look at the item difficulty itself, or the point biserial. We could give you this information, and I could ask you again, would you like to change your judgment as a result of this information? However, these are all variations on the same theme. Basically, you are required to give an estimate of the borderline candidate passing this particular question. We then average the values across the different judges, and we repeat the procedure for the next question. You can imagine this is quite a horrendous task. You need to work through all the items in the test, and it's quite a task. It requires quite some time and effort from your judges. The literature has shown that the ENGOF procedure produces reliable, reproducible passing scores if you have a sufficient number of judges. And the literature says around 8 to 10 judges in a panel is sufficient enough to produce rather reliable outcomes of passing scores. The second validity issue, if you wish, which brings credibility to the procedure, is the fact that the ENGOF estimate, the average judge ENGOF estimate per item, correlates with the item difficulty. Or yet in other words, apparently judges judging the items weigh the item difficulty in their judgment, and to some extent they reconcile the item difficulty and therefore the test difficulty in the passing scores. With a set of more difficult questions, they will adjust their passing score, and conversely with a set of more easy questions. A third argument that brings evidence, or at least arguments, to their credibility is the fact that you use a panel of experts making a lot of effort to define the passing score. As you may now see, the biggest downside of this exercise is resources. It requires a lot of time and a lot of effort. However, I should say that virtually all certification agencies around the world using and developing certification exams all use Angoff-like procedures for their written tests. It is kind of the accepted standard. If you have the money, that's where you go. Right. Now, suppose you don't have that money. We need to find something else. We are moving from absolute standards to more relative standards because they are more cheap and more easy. Naturally, they have side effects, but we'll look at that later on. One approach is the judgment of individuals, and the method that is being used is too popular one is the borderline or the contrasting groups method. They're kind of the same, which I'll show you in a minute. But let's assume that we have an OSCE exam. In an OSCE, we have a criteria list, a set of checks on a checklist. Usually this is the sum score across the items in the checklist, provides the scores on the station, and we average that across all stations, and we get a test score distribution as is displayed in this particular slide. However, in addition to completing the checklist, we ask the observer within the OSCE station, the examiner, to also complete an overall judgment. We ask that person to complete a pass, fail, or borderline decision based on the integral judgment and overall judgment of the performance of the particular candidate in this particular station. We use that information to arrive at a standard. What we do is, from the total test score distribution, we first assemble all the passes, all the students who pass. We take their overall test score arrived from the checklist, and we make a test score distribution of that. So this is a sub-distribution of all the scores of all the people who passed. We do the same with the people who have failed, and this is the fail score distribution. Well, you might imagine that there where the two distributions overlap, we have the passing scores. Okay? That passing score is then applied to the total test score distribution, and that is your cutoff, your final passing score. This is called the contrasting groups method, because we took two contrasting groups, the passers and the failures. We took their score distributions. There where the distributions overlap, we have the passing score. The variation to this is that we have we pick out only the borderliners from the total test score distribution, and we plot that and take the average of that and use that as a passing score. The downside of it is that there are probably not too many borderliners, so the reliability of picking the average score of the borderline distribution is probably not that high. There is one variation which is applied to this method that is often used